This is the end, beautiful friend. This is the end, my only friend. The end of our elaborate plans. The end of everything that stands. The end, no safety or surprise. The end, I'll never look into your eyes again. Can you picture what will be so limitless and free? Desperately in need of some stranger's hand in a desperate land. Lost in a romance, wilderness of pain, and all the children are insane. All the children are insane. Waiting for the summer rain, There's danger on the edge of town. Ride the King's Highway, weird scenes inside the gold mine. Ride the highway west, baby. Ride the snake, ride the snake to the lake, the ancient lake, baby. The snake he's long, 7 miles. Ride the snake. He's old and his skin is cold. The West is the best. The West is the best. Get here and we'll do the rest. The blue bus is calling us. The killer awoke before dawn. He put his boots on. He took a face from the ancient gallery and he walked on down the hall. He went into the room where his sister lived, and then he paid a visit to his brother, and then he walked on down the hall, and he came to a door, and he looked inside.
All right, so today is just a course retrospective. We'll understand what a retrospective here is in a moment, but I've been doing them all semester, hopefully, if you've been following along on Piazza. So basically, it's an opportunity to reflect on the course and understand what went well, what didn't go so well, and what can be improved for the future. A retrospective is part of the software development process. The software development process that we set you up for this semester was the agile process. We didn't introduce it in a formal notion, instead we organized it that way for you, where we've got sprints. So now in the real world, typically sprints are maybe 4 weeks or a month or something like that. At the beginning of each sprint, the team, which is usually a self-managed team, the team members decide what they're going to commit to for the next 4 weeks. And then at the end of it all, they have a retrospective of what went well over the last 4 weeks, what didn't go so well, what can be improved for the future. Because the idea here is what you're doing is at the beginning of the sprint, you are committing to a certain amount of work. And so here's your amount of work. At the end of the sprint, you should have 0 work left. But you don't want to see these highs and these lows of activity. So for example, you don't want to see okay, well, we're not getting anything done. Now we cram and get everything done on the last final day, right? That's not how things work, or that's not how they should work, because you're working at the very last minute, you're not putting in your best effort, you're not thinking about the design first, etc., and you're just getting it done. Likewise, you don't want to have, a precipitous drop-off right at the beginning, and then we do nothing for the rest of the month, right, or the rest of the sprint. Because that means that you didn't estimate your time properly. What you want is this nice, it's called a burn down chart. You want this nice linear burn down chart where you're working at the same pace every single day of the entire sprint. So you're not, you don't have these low points of no activities and these spikes of cram activities. You want everything to be predictable and you want everything to be steady, right? At the end of that entire process, you have a retrospective and you say, okay, we did this right, we didn't do that right. We estimated correctly on this, but we didn't estimate it correctly on this. Lesson learned, we'll go ahead and go forward. Likewise, this retrospective is going to be looking at the entire course, maybe even also your whole year if you want to look back and reflect on your first year at the School of Computing. Before we do that, though, I would mention that the course evaluations are still open and will be open for some time after finals week, I think. That's your opportunity to give me a retrospective. You tell me what went well, what didn't go so well, and what can be improved for next time for the future. In this section, there are 91 people that are eligible to take it in the in-person section, 33 people in the online section. So far, only 27 people have filled that out, and so the response rate here is only 21.8%. I would highly encourage you at some point before they close to go in there into Canvas and make sure that you are filling out this course evaluation. Don't just fill it out to fill it out. If you don't want to fill it out, fine. That's fine too. I mean, no news is good news in my book. So the response rate is a factor in all this, right? If we're oftentimes you'll hear people, the squeaky wheel gets the grease or something. But make sure that you're filling it out honestly, right? That you're putting in constructive feedback, that this worked and why did it work? This didn't work, why didn't it work, right? Don't just fill it out with garbage just to fill it out. right? But otherwise, the course evaluations are your opportunity to give me a retrospective. And I do pay attention to them, and I do listen to them, and I do make effective changes based on them when there are effective changes to be done, right? So reflect back on this entire semester, reflect back on this entire year. What lessons have you learned? What skills have you acquired, and what achievements have you unlocked if you want the gaming perspective on this? Hopefully from this course you've had far more exposure to those soft skills, the so-called soft skills of teamwork, conflict resolution, and coordination. Not everybody chose to work in pairs, but those that did probably had to perform some of this. If you had a 100% excellent experience with your partner, you still had to, coordinate with each other. You still had to go back and forth and say, well, have that debate. I think that this design is the way to go. I think that versus I think this design is the way to go. You still had to have those conversations, those communication skills. If you didn't have a 100% awesome experience with your partner, then you had to work on the other two parts, right? Conflict resolution. There were plenty of people that had to drop their partners, find other partners, or that were dropped by their partners for various reasons. How did that go? How did you have to have that difficult conversation of, you're not pulling your own weight, or this partnership is not working out? How are we going to move forward? And so, these are things that people think, or some people say that you can actually teach these things. Really, in my opinion at least, they're only acquired through experience. Which is why we don't require partnerships or teams up front in this course. You're going to have to work in teams eventually. So you're just going to have to accept it at some point. But early in your matriculation, I don't like requiring teams because you don't have the exposure to these valuable soft skills. And it's only through this process of trial and error and having these bad experiences that you start acquiring these things. Later on in computer science, software engineering, like 361, you will be required to work in a group. And guess what? You don't get to pick your pairs, right? You don't get to pick your group. When you go into industry, you don't get to pick the team that you work on. You get to pick the company that you work at, right? You don't have to work at company XYZ. You can go ahead and go with ABC. But at the end of the day, you don't get to fire other people unless you're the manager. So at some point, you will be working with somebody that doesn't pull their own weight. How do you work around that? How do you approach that and try to resolve that conflict and understand why are they not pulling their own weight, right? Like I said in one post, that there have been several instances where academic integrity, we can't catch everybody. We can't litigate everybody, right? There are going to be people that probably get through this course by the skin of their teeth, having gone to Chegg or Chat GPT or something like that. You're going to have to work with those people, right? And it's an unfortunate reality, but you're going to have to work with them. And so some of these soft skills are going to come into bear, right? I wouldn't want to work with somebody like that. And if you are out there and you are one of those individuals, good luck. Start pulling your own weight somehow, right? Hopefully you've expanded your toolbox, right? You probably have now at least a second programming language, if not a third, SQL. Maybe it's your fourth programming language or something. You certainly have more exposure to an object-oriented programming approach. And of course SQL. And hopefully you've been using Git on a daily basis, especially if you're working with a partner. If you're working with a partner and you're exchanging things over email or a flash drive or something like that, you're doing it wrong, right? Just learn Git. It is a de facto tool nowadays. It is an absolutely essential skill that you need. We try to give you exposure to it by showing you how to do it with Eclipse, by showing you how to do it from the command line, making you clone every single lab, et cetera, right? But we can't, you can lead a horse to water, but you can't make him drink. We can show you Git. We can't force you to use it until you just look around one day and see that everybody else is doing it, and you're still passing back and forth a thumbnail drive or something like that. Get with it. It's 2023. Right? Hopefully you have some experience and perspective building a larger project. In Computer Science 1, typically what you do is a bunch of just weekly exercises or small contained programs or something like that. This project built on each other, each phase built on each other. And so you got to experience what it's like having to deal with bugs in a previous phase or a design that wasn't so great in a previous phase and having to use that and fight that maybe in another phase. Or you saw the benefits of planning up front, testing proper design up front, and you saw, oh, wow, it's way easier to write my list now because my invoice class has a get totals method. All I have to do is call that method and now I can sort it, right? Something like that, keep it sorted. Hopefully you also have exposure to technical writing. This is something you're going to have to do throughout your careers. Whether or not you're actually creating an IEEE design document or a requirements document or something like that, you will have to have exposure to technical writing. Even if it's just writing up an email or creating your resume or something like that, it's still writing and you still need experience of it. And I really like that we've introduced the idea of technical writing early in the curriculum instead of way later in the curriculum as part of this course. So yeah, it's a pain, right? It's just like documentation in a code base. It's not the most fun thing in the world to do, but it's the absolute valuable and essential skill, right? I don't know. Some people do like writing. Some people do like technical writing. Right? In any case, hopefully you have better appreciations for technical debt. Technical debt is when you just get it done. You throw it together. You're taking out a loan on your future time. In fact, you're taking out what's called a blind call, I think it is. So you can in commodities trading or in stock trading, you can say, I'm going to sell a contract whereby I will buy or sell a stock at any price 1 month from now, right? And somebody pays me for that contract. Now, if that price goes down, great. They're not going to exercise that contract, and I just made a bunch of money. If it goes up, right, if Google stock goes up, then I am going to be forced to buy it at whatever share price it was that day in order to fulfill that contract. In other words, there is unlimited risk. It could be $1,000 a share. It could be $10,000 a share. So it's not really like a loan, because a loan, you take out $10,000 to purchase an automobile, you know exactly how much you have to pay back, $10,000. You know exactly how often you have to pay it back monthly, and you know exactly how much interest you'll be paying. With technical debt, you don't know any of that, right? I'm going to go ahead and throw it together, and it's a bunch of dog food, right? I'm going to have to be forced to eat it later on. Right? And I'm not going to like the taste. In fact, to find the time to do it over, it's going to take me, say, 10 hours, 20 hours, 30 hours, 100 hours. I have no idea, right? Because I just threw it together at the last minute. Hopefully you understand that procrastination is not an option at all in this discipline. I don't know about other disciplines. I don't think it's an option in any discipline, but certainly not this one. Right? Hopefully bad practices have become apparent why they are bad practices. The design as an afterthought rather than doing it first. Because if you have a bad design up front, you're going to be fighting it later on. If you didn't design your store class with a list of invoices so that you could compute the total at that store, there's no way that you're going to be able to implement and design a sorted list to hold that stuff. If you didn't design your invoice class with a get totals method or something like that, then you've basically broken encapsulation, and when it comes to the last phase where you're designing a list, there's no way that you're going to be able to design it properly. Right? The usage of good test cases and good test suites. We weren't expecting a lot. We were expecting maybe three of each type of, at least one of each type of item. At least 3 invoices, right? How many do we have to have? Well, you have to cover your code. You have to make sure that you're testing leases and that you're testing products, etc. Some people only tested products, and then why are my leases off? Because you didn't read the instructions and it was 1 day off. You have to be inclusive on both ends. If you had designed a good test case that actually tested leases and equipment purchases, then you wouldn't be in that mess 3 phases later, right? Hopefully poor variable naming hopefully you got broken of that bad habit out of Computer Science 1. But if it remains, then you see why it's even worse now, right? If you called something a person and it wasn't a person, right, then how can you expect it to act like a person? If you modeled your person just as a code in the manager, a manager's just a code in the store class. Who the hell actually manages the store? If I need to print out their last name and first name, how am I going to find that, right? That's a poor variable name. It's poor encapsulation. Hopefully you've also seen over-engineering, right? And why you don't over-engineer things. Yagni, right? You ain't going to need it. A lot of people had like a weird name class where it was a first name, last name. Why? It just made it way more complicated. A lot of people used a class per table or table per class inheritance strategy instead of the one that we suggested, one single table. And so they had a table for items and then also for products and equipment and what was the other one? Services. And then they also had 2 more for different types of equipment. So they're sitting here with 6 different tables, right? Where keep it simple. You ain't gonna need that, right? So don't over-engineer things until you absolutely need to. Right? Again, what's better than good in engineering? Good enough, exactly, right? So how do you know about perfection too? There's another saying like this. How do you know when something is done? How do you know when something is perfect? Not when there's anything left to add, but when there's nothing left to take away. Right? When you've stripped it down to the essentials and you've kept it simple, KISS principles, right? Yagni, better than good, right? All those things are basically the same idea. You've seen bad database designs and fighting those bad database designs, right? Remember, one of the themes of this course is be okay with throwing one away, right? If you had a bad design, you should have been okay with going back and throwing it away entirely, refactoring it, right? Oh man, I put 10 hours into that 500 lines of code file, right? So what? You learned something from it. Throw it away. Go back and you'll write a much better file with only 100 lines of code that now achieves stuff and that you're not fighting that design, right? Make sure that you are comfortable with that. Don't get married to your code, right? Code is just code, right? All right, oops, all right. There we come back over here. All right. Hopefully, overall, you're just better. You have a better appreciation for the scope of a larger project, working and coordinating teams, et cetera, et cetera. Hopefully, you're better coders overall, and you're better designers. One of the best student evaluations comments that I've ever seen was a student that did a self-reflection and thought, you know what, I came into this course or last course or whatever, I came into the year struggling with writing a basic Hello World program or FizzBuzz program. And then by the end of the first year, I was a coding machine. They looked back at themselves at the beginning of the year and they saw how much they had improved. And that's what I tell everybody in Computer Science 1. Don't compare yourself to that individual that's been coding 4 years in high school, and before that they were throwing together Roblox, whatever it is, Roblox games and Lua, right? They have way more experience than you. Don't compare yourself to them. They're able to get the assignment done in 1 hour. They were able to mash it out in just that quick. Don't compare yourself to them. Compare yourself to yourself. If you can look at yourself at the beginning of the year, beginning of the semester, and at the end of this year, at the end of the semester, and you can see, honestly say, wow, if I had it to do over again with that first assignment, I could hammer that out in like less than a third of the time, right? That means that you've improved, right? That's what you should be looking at. What were the impediments? So that was the good. What was the bad, right? What are the impediments that students faced? Unfortunately, the number one issue is never really getting started. It's impossible to finish a race if you never get out of the gate, or if you never cross that, not the finish line, but the starting line. And we'll see that here in a moment when we look at the grades. Procrastination, always procrastination. I've tried to fight this over the years with various techniques and various approaches. My most recent one being the introduction of a Gantt chart. How many people followed the Gantt chart all the way to the end? Okay.
I didn't follow it, but I modified it for my
All right, you modified it and you.
sleep schedule at least.
Oh, yes, gave you a sleep. You put sleep on the Gantt chart, sure.
Yes.
Right. in any case, you're going to have to self-organize at some point. And if the solution is a Gantt chart, great. If the solution is something else, great, right? Whatever works for you. But the point is that you need to self-organize. You need to there's got to be a self-discipline in there somehow. We tell all incoming freshmen that you're not in high school anymore where everybody's setting your schedule, you're within the bounds of your parents or whatever, right? Now it's on you, right? And it's unfortunate that we just flip a switch and you turn 18 and go to college or you go out in the world or whatever, and now you're on your own, right? And so, I try to ease that transition a little bit by giving you some well-proven techniques, well-proven tools to do that. Agile development, being able to plan a sprint, being able to plan 4 weeks, or our sprints were actually 2 weeks. I plan them for you and map them out. Here's what you need to do here. Here's what you need to do here. Here's what you need to do here, because it logically builds on each other, right? When you go into an actual firm, or when you go out there and start doing your own development, that falls to you and the rest of your team. The whole point of agile development is that you do not have pointy-haired bosses telling you what to do and when to do it. Instead, of the whole point of agile software development is that you are a team that has the technical know-how and skills to be able to self-organize and self-manage. In agile development, you don't have bosses. You have product owners and scrum masters and whatever else you've got. They're not really there to tell you what to do. They're there to tell you what they want. And then you say, okay, great, we could deliver that in 8 weeks. Here's how we would split it up. If that's good, then give us the green light and we'll do it, right? Once you've got a sprint and you've got that 4 weeks and they've committed to this work and they've signed off on it, they're not supposed to be able to come in and say, drop what you're doing and put this fire out over there, right? Nope, that ain't my job, right? My job was committed to at the first 4 weeks, and that's what we're going to be doing here. If you want to put that on my backlog, we'll go ahead and consider it on the next sprint, right? But you don't have somebody coming in and yelling at you and context switching you out all the time. But with that great, what is it? With great power comes great responsibility, right? Then the responsibility falls to you to do that planning. Right? Hopefully you understand that design comes first. That part of procrastination was not designing things to begin with. Less than half of the individuals in this course actually came up with a cogent and coherent design document 1 week beforehand. But let me tell you, the ones that did, they got enough feedback that their design was perfect, right? Trust me, trust in that process. You're not going to have that process going forward outside this class, but adopt that as your process. 1 week beforehand, I will have this done, so that I know I can foresee any problems in the future. Yeah?
One problem I had with the design document is because I missed that Monday where you had the person coming in and like describing the like writing assistant, I never really understood what was going on. So until like my 4th revision, I didn't get any feedback on the design doc whatsoever.
That's a good point.
Like,
So
if someone didn't have a good design doc, or like a functional design doc beforehand, I don't think they got any feedback whatsoever.
true. So. Well, okay, so that's a good point that you should bring up in the course evaluations, because I've asked my TAs this before, and I've been wondering, is this course unique? I mean, if you miss a day in Calc 1, are you screwed? No, but how do you make that up? Do you go to somebody and ask for their notes? Okay. Well, can you do that here?
Well, not by the rules say that you can't get outside help for cheating.
Well, that's not, getting somebody's notes is not outside help, though. What I'm asking about is, I live stream this. Should I stop?
No, you're good.
All right, so then I miss a day. What's the resolution to that?
I missed a day. I was pointing at because my design doc, I did not know what to do at the start. I turned in design document drafts that were not like design documents, and they didn't give me feedback on what the hell I was supposed to do.
Okay, all right.
I asked about it, but I couldn't get much feedback on the design document draft that I was given.
All right, so different problem, but it's still up for discussion, right? Should I stop this?
No,
right?
you're good.
Because, well, no.
I didn't get feedback on the design doc, so this could be either a problem of procrastination or a problem of the feedback given.
Right. All right, thank you. But the overall question still remains, because there are far too many people that see, oh, wow, I don't have to go to class. Right? I'll just go ahead and watch it later. Guess what? They don't watch it later. Right? When we get questions like, how do you analyze an algorithm? Right? Well, have you been to class in the last month? Right? Have you been to class in the last 2 months? No. Have you watched any of the live streams? Have you watched any of the pre-prepared videos? Right? So I mean, this course gives you a lot of resources and a lot of advantages, but with that comes, again, with great freedom comes responsibility. Do we need to take that freedom away in the future? Right? And there are people who are saying yes, and are in the background saying yes. That you shouldn't do live streams like this. You should force them to come. You should force participation. You should have clicker questions so that they're forced to come and sit there and watch you and do everything. Right? I don't really believe in that. Right? But as a matter of practicality, I mean, look around you. What did we say? 90 people in this course, and how many are here? Right? So you tell me. This is the course evaluation, right? My take on this, at least there's another group of opinions that say, screw them, right? If they can't get their stuff together, then who cares, right? I still want to see these live streams. I still want these resources because they are valuable to me. Those voices need to be loud, right? Those voices absolutely need to be loud, right? They need to be in the student advisory boards. They need to be in the student advisory panels. They need to be screaming at the top of their lungs in the halls so that people actually hear this, all right? So keep that in mind. Anyway, back to the actual one here. Hopefully you've seen the insufficient testing, right, is another huge impediment. That you should always be testing your code. It doesn't have to be fancy, right? It can be ad hoc testing, but it should be, formal, right? It should be, if you can run code, you can run tests. If you can write code, you can run repeatable tests. You can run repeatable tests. You can probably maybe write repeatable tests. But if you can read code, then you can write proper unit tests. You can write proper JUnit tests. And why did I put it in this order, by the way? If you've ever heard of Bloom's taxonomy, you have higher order cognitive skills up here and lower order cognitive skills down here, right? Where the lower order cognitive skills are just understanding something. Way up here, you have creation, right? It's actually reversed for coding. There are papers on this, where reading and understanding code is actually way higher cognitive skill than just writing code. This is why our attempts at giving out code always fail. After that first bad assignment, people were asking, well, can you give me a code base to start with so I can go forward? Yeah, we can do that. Here you go. Guess what? It doesn't work. Why? Because reading code and understanding somebody else's code takes a far higher order of cognitive skill and experience than it does to simply just pre-produce that code from scratch. Trust me, this is documented research. And it's because Bloom's taxonomy is reverse on this. So if you can read code, you can write proper unit tests. You can see this code over here that somebody else wrote, and you can say, you know what? I don't think that they took care of this particular case over here. For example, there's a linked list implementation. Did they ever bother testing this by inserting into an empty linked list? Did they ever bother testing this by inserting at the head of a list with 5 elements? I can write those proper unit tests here and break their code. That's what you do when you write unit tests. You try to break code. You try to break it, and if you can't break it, wow, that's good code. It's really resilient. Right? Okay? If you look at the syllabus for this course way back at the beginning, usually they have like topics in syllabi. What I do is I list out the skills objectives instead. So have you acquired these skills? After the end of this course, successful completion of this course, I should say, you should be able to more easily pick up and learn a new programming language on your own. Right? Now that you've got 2, 3 programming languages, all you have to do is say, well, I know how to do it in this programming language. I know how to solve that problem. how do you do file I/O in this programming language, right? And it's just simple lookup, a simple Google search on Stack Overflow. You should be able to recognize, use, and design and appreciate programs with an object-oriented flavor. You should be able to design a database-backed application from scratch, given a general purpose problem. You should be able to understand and implement basic data structures, when to use them, when not to use them, because if I use that linked list data structure over there, I know, in this manner, I know that that painter is not picking up his paint bucket and taking it with him. You should be able to identify and analyze basic algorithms. Right? So one way of thinking about this is thinking about, well, first of all, the Eric S. Raymond quote again, that the smart data structures in dumb code are a lot better than the other way around. After having gone through Computer Science 2, you should have a different approach than having gone through Computer Science 1. Computer Science 1, you take a problem and you break it down into smaller and smaller parts, chunks, until, oh, there's a library function to do that for me. Or, no, this is just one line of code, right? Or it's just so simple, you just write it, right? But by the end of a Computer Science 2 course, you should be asking bottom-up questions first. What entities or objects should you design in order to model this problem? Oh, okay. I'm going to have to sell stuff to people. Okay, I need a people. I need stuff. Well, what is stuff? Oh, it's equipment, and it's this and products, this and this and this. All right, how do those interact with each other? Well, I'm going to need a report that says that there were 50 sales at this store. Probably then the store needs to own a report or own a list of items that it's sold, or invoices or whatever, right? Those are the kinds of questions you should be asking first. How do these objects interact with each other to solve the problem? And what data structures can you pull off the shelf because you recognize that problem as a sorting problem, or you recognize that problem as a last in, first out problem? Okay, I'll just pull off a stack, or I'll pull off a heap, and I'll apply it, put stuff in, take stuff out, it's done, right? The big takeaway from all of this is that you may have done some things wrong. That's part of the learning process. That's perfectly fine. Or a lot of things poorly, right? But the next time you do a project, the next time you do something like this, you will do better, right? You'll still get things wrong. Don't worry. The third time you do it, you'll do it even better, right? Even better, even better, even better. That's what you should be focusing on. How am I going to approach my future courses and my future career and that project and the next project and the next project? The other takeaway that you should have after your first year here is that computer scientists, computer engineers, software engineers, whatever you want to call yourselves, you have to be everything. You have to be lawyers, you have to be philosophers, diplomats, managers, designers, creators, thinkers, writers, and programmers last. Why did I put programmers all the way at the bottom?
Anyone can type the code.
Well, anybody can type the code, right? Nobody's dictating code to anybody these days, right? But I don't know if I posted, Kevin should have posted this at some point. Maybe it was last semester. There was a meme where there's this nice little chart where you're a beginner programmer, so you only write 10 lines of code per minute or something. And then you're an intermediate programmer, and now you can write 100 lines of code a minute or something like that, right? And now you're a little bit more advanced, and you're writing 1,000 codes an hour or 1,000 lines of code an hour or something. Now you're the true expert, and you are writing -3 lines of code per hour, right? What does that mean? You are taking away the garbage and throwing it away. You are refactoring and you have such an expertise that you are taking things away and making it better. Right? That's what good programmers do. Right? The software engineers, computer scientists, right? If you think about it like a 40-year career, 50-year career, if you're so lucky, the amount of programming that you do is very, very small compared to everything else. And not only that, but over time, the amount of programming that you do dwindles until your programming is nothing more than telling somebody, nope, that sucks, redo it. Here's how I would redo it. I would take away this, take away this, take away this. Right? That doesn't need to be there. Yagni, you ain't gonna need that. Right? But you do have to be all of these things. And in case you think that you don't have to be one or the other, you do. Just this last week, I had to deal with a bunch of copyleft trolls. Have you ever heard of that term? Where, somebody releases a photo under a Creative Commons license, meaning that anybody can use it for free as long as they attribute it. A student had used a photo of, and a copyleft troll, pixie.com, basically sends out automated bots looking for violations of this copyright by somebody not putting the name absolutely clearly, right, of the attribution. And then, of course, they go for a shakedown. You pay us $750 and we can make this go away, right? No. Do you respond to them? No, right? You're not a lawyer, but you're enough of a lawyer to know that you're not a lawyer, to know that you shouldn't be talking to other lawyers. You shouldn't be talking to cops. What you do is you lawyer up, right? Anytime you face a legal threat, that's it. No, not a single additional word, period, right? Instead, you go to the lawyers and you say, you deal with it because you're the lawyer, right? A colleague...
You're not a lawyer, but you know what goes where and how it falls.
you need to be enough of a lawyer to know when you're out of your league and that you need a lawyer, right? Which is all the time, right? A colleague didn't. A colleague immediately, was I think that they replied and they were very apologetic. Never be apologetic. Why? Because that admits fault, right? And a lawyer, that's gold to another lawyer, right? No, lawyer up. You have to be philosophers. You have to be diplomats, right? Conflict resolution. You have to be designers and creators and thinkers, right? All of these things you've had to be this semester, trust me. Here are the end of semester stats for this course. After everything is graded, we'll have an update here. 154 were originally enrolled, right? Of those, 69 currently have an A, or this is without assignment 8 or the design document. There are 33 individuals who have accrued enough bonus to have 100% or greater, right? There are 26 Bs, 9 Cs, 5 Ds, 15 failing, and 30 people ultimately withdrew from this course because they were going to, there were a couple with, decent grades up until they withdrew, but the vast majority did not. This is basically 2/3, 1/3 split. So 2/3 are passing the course, 1/3 are not passing the course. Good, bad, I don't know, certainly ugly, right? But it's not historically bad. Let me go ahead and run down to the bottom here. The typical DFW rate, the typical failure rate of this course is about 20 to 30% for majors. That's computer science, computer engineering, and for whatever reason, software engineering that are taking this course. So we're a little bit higher on the end, but overall it's actually comparable. In fact, slightly better than usual, right? I think that about maybe 35, 40%. If you look at non-majors, they typically have a DFW rate of like 35, 40%. Predictable because it's not really a non-major course. But that's a historical perspective. So it's basically no different than any other year, right? It ain't special. The other stat that I would share with you is how people passed or failed this course. So this is the weekly, week-to-week distribution of grades. Blue here are A's. Over here in week 0, everybody was getting an A. Why? We gave you free starter points. Right? Over here, week 15, everybody's failing the course. Why? Because we haven't graded everything yet. Don't worry about that. We're only in week 14 right now, technically. Right? But look where people started to lose it. Where? Week 3. What was in week 3?
What was that phase 2?
No. What was in week 3? Assignment 1. In other words, people just didn't do assignment 1, right? Or they did half of it. They did the two. They did the first two. The freebie ones. The corn, like computing a corn silo or something, and then the other one, right? And it basically solidified by week 7. Oh, is that 7? Yeah, by week 7, the grade distribution was set. But that trend is basically set in week 3. Again, the biggest impediment is never really getting started. You can't cross the finish line if you don't step out of the gate. Right? It's unfortunate. I don't know how to solve it. I've engaged many people over the years on what's the problem. Right? Unfortunately, in that course evaluation, those who withdrew are not going to be able to give any evaluation. So what I would ask you to do is when you fill out this course evaluation, tell me their stories or have them tell you the stories. Many of you have probably discussed this with some students that have fallen by the wayside. what was their issue, right? Why didn't they step out of the gate? Why aren't they crossing the finish line with the rest of you? Right? I'd really like to know. Right? All right, so there's the distribution. Course conclusion, you still have assignment 8. You still have the design document. Make sure that you're reading our feedback. If you got some feedback, otherwise make sure that you're reading our Piazza posts where we gave general feedback. There's no, of course, final exam. I believe in formative assessment rather than summative assessment. I don't know how your other STEM courses are going, but traditional STEM courses are like 90% exams and you only got 3 of them or 2 of them or something like that. I don't do that, right? I believe that you should be able to hand stuff in again, resubmission of one assignment. I believe that you should be able to submit and resubmit as many times as you want and improve it up until that due date. Final stats, of course, will be posted on Piazza. Where do you go from here? One thing that I would be concerned about is a little bit more in this semester because I took a even greater depth on grading myself, is overly generous grading. I saw unfortunate, but I saw many instances where LAs were way too generous or they missed certain things. And so you may have the misimpression that you had an awesome design. Right? I don't think that this is endemic, but do keep in mind, like, oh, maybe my design wasn't that great and they just missed it, right? Talk to somebody, right? Come in during office hours, help hours. Talk to other students after it's done. So while it is done, you can go ahead and talk to each other now on your designs and ask, how did you do that? How did I did it this way, and discuss. Oh, wow, they really missed out on docking you points over there, right? As far as academics are concerned, most of you are probably in discrete math right now. And if you're moving on next year, you're probably going to take Computer Science 3. That's going to be CSCE 310, and it's going to be a continuation of data structures and algorithms, right, where we leave off in this course. Many of you should, anybody who has successfully completed this course is more than qualified for an internship. Do not think that just because you're a freshman, you can't get your first internship after your first year. Most people do, right? So if you missed out on the career fair in the fall, you missed out on the career fair in the spring, fine. Make sure that you're not missing out on them next year and get that internship for either next year or the next summer. Stay frosty, right? Over the summer, learn a new language, build a project, do something, right? If you've got a job, fine, make that your focus. If it's technically oriented and you're doing development on a daily basis, great, then you're staying frosty. But if it's not, you're doing something else entirely. Your age group doesn't detassel anymore, but let's say that you go out and detassel instead, right? Then on your off hours during the evening, build some sort of a project, right? Just stay frosty so that you don't come back into Computer Science 3 not knowing how to program anymore, right? Stay in touch. Hopefully you are part of the Discord already. If not, make sure that you are joining the Discord. This is the Student Advisory Board Discord. They do send out bits and bytes, but only every other week or something like that. But there's the Discord invite. Hopefully it's still active. It's like 2 or 3 years old. It should have been a non-expiring. Oh, it is good. It should have been a non-expiring invite. Once you do that, then get on the other Discords: UNL Game Development Club, OS2G, Red Teams, Research, Education, and Development Teams in the College of Engineering. I am leading one of the teams right now who is going, and they were just in the Bits and Bytes news. They're going to be going down to the Johnson Space Center next week. I'm not going. But they're going down there to test their HoloLens project in front of NASA at the NASA Rock Yard. Right? Getting involved in departmental things like that, opportunities like that, how did they know to get involved? They probably read, Bits and Bytes. Oh, wow, Red Teams? I wonder what that is. I'm going to go ahead and join them. OS2G, they're giving a free seminar on GitHub, using Git. Wow, I'm going to go there. Oh, wow, I'm really interested in developing games, right? I'm going to go ahead and learn Unity or, what is it, Godel? Or what
Unity, there's...
I thought it was Godel, Godol. Okay, whatever it is. Right, join those clubs, right? Those are the 3 that I'm naming off the top of my head because I'm involved in them all. There are plenty more than just that I don't know about. So make sure that you know about those clubs. Otherwise, thanks to everybody who took this course. Thanks to everybody who helped on Piazza. Double thanks to all the learning assistants and course leaders throughout the semester that helped with this course. Thank you to everybody who took this class, and have a great summer.
And thank you for teaching me, by the way.
Sure, thank you.
Other people complained, but I thought you were really fun.
All right. Hopefully not too many complaints.